For the past years, we've been tackling the various consequences that our use of fossil fuels have brought us, thus driving the vast research on sustainable energy such as solar power and wind power, both of which can cover the global energy demand. But that is only if we can store it. Large amounts of electricity cannot be stored and must be generated as they are needed. By generating hydrogen fuel from water using electrolysis with excess energies from renewable resources, large energies can be stored and transported in the form of hydrogen fuel. Hydrogen is a flexible fuel as it can be used in different forms. It is currently used as car fuel, jet plane fuel, and rocket fuel through fuel cells or combustion. John Wei Miao, leading researchers from Taiwan and Singapore, presented a study on the creation of hydrogen fuel from water using a carbon fiber composite to create a cheaper and more efficient synthesis of hydrogen fuel from water. Commercially, water is split by running a current on a metal electrode coated in platinum catalyst in an acidic solution. But there are some problems, such as the fact that platinum, though really expensive, is hard to replace because it is very effective. The system is also not stable as platinum gets poisoned by the acid in the solution. To face these challenges, Miao's team created nickel-molybdenum sulfide nanosheets coated carbon fibers. Molybdenum sulfide is made up of components that are hundreds of times more abundant than platinum, making it cheaper. And although molybdenum sulfide is not as good as platinum, addition of nickel creates more active sites, raising catalytic activity. According to their research, the new carbon fiber composite is much more stable over an extended period of time, and its flexibility means it can be used in multiple reactor designs. It also runs at neutral pH and on seawater, possibly reducing water treatment for feeding into reactors. A patent by Chinese researchers shows similar efforts in trying to solve the problems of the use of platinum-coated electrodes by the pairing up of graphene with molybdenum sulfide. The patent, though similar in the use of molybdenum sulfide and carbon-based material, have no claims over the use of nickel as a way to increase catalytically active sites. Hydrogen fuel from low-cost electrolysis of accessible seawater will have the greatest public impact on two industries. First is in transportation. Car manufacturers have been creating cars made to run on hydrogen fuel. In some countries, the government even funds part of the projects as investment for public transportation and lowering of emissions. Hybrid cars for disaster vehicles, a current project in the Philippines, make use of fuel cells. By using a partition of the solar cells to generate hydrogen fuel from accessible seawater, more energy can be stored and transported to power important facilities. Another market are power plants and countries without proper electric reserves. With the composite's flexibility, it can be used in multiple reactor designs, so outfitting existing power plants with cells is relatively less challenging. In the Philippines, we experience annual blackouts due to the lack of reserves because we can't store large amounts of energy. But the Philippines is an archipelago. We are surrounded by seawater which we can easily access to be electrolyzed for hydrogen fuel. In this electrolysis, we can use rising renewable energies such as solar power, wind power, or ocean thermal energy. Wind power is actually already being used in the Philippines to power cities. The Philippines is also one of the few countries found to be viable to use ocean thermal energy conversion. We can even outfit our current power plants. Innovations that make use of this would not only help in decreasing the carbon footprint of the Philippines, but also solve one of our annual major problems. The synthesis, therefore, of hydrogen fuel from water using carbon fiber composites does not only open the way for global decrease of carbon emissions, but can directly affect us through its potential to create a better power management system for our country.